this is the refrigerant line that we are using to install our mini splits. We have 1/4 inch, which is really tiny, and 3/8 for most of them. The bigger mini split unit is a 1/2 inch pipe. So it's the liquid line, the discharge line. And in refrigeration, the type of connection they use is called an SEER 45-degree flare. So basically this tubing gets bent out and makes a 45-degree angle, and that presses against the male part of the connection, and then you twist down a compression nut and it presses those two flare surfaces together and makes a seal. So it's really important that you can get a nice, clean, scuff-free, scratch-free flare connection. So we had to iterate a little bit with flaring tool. The first kind we bought was this style. It comes from like AutoZone. It was literally $10, but you basically clamp the tube into the fitting. So you undo these little wing nuts, and then you tighten the fitting down. So you put it in this clamp, and then you put this flaring tool on, and as you spin this screw, it pushes the die up against the other die and drills a flare. This doesn't work very well because this tool just goes straight down and it ends up just scraping along the surface, so you end up getting a not very good flare. We also got a lot of tearing with this one. We tear the little edges of the pipe. So we iterated. We got a slightly more expensive tool. It was maybe $30 on on eBay. It's called an Eccentric flaring tool. It's actually much better because if you look in there, as I spin this, the die kind of rotates. So instead of just pressing and scraping against this flaring surface, it kind of rolls. It's got a bearing in there so it can spin. But the seller sent this thing loose in a box. It was supposed to be new. You need this part, and you need the mating die that goes specifically with this tool, so it's just completely useless. The guy's yet to give me a refund too, so not a positive experience. So what we ended up buying instead was this Master Cool set. It's like $100 on Amazon. Which is a lot more than these two options, but in the set comes, it's got a cutting tool for cutting the pipe, I don't think we're going to end up using this, but a reaming tool, and it's got this part, which is pretty much the same as that one. I think they're all kind of like made from the same mold. But then it also has this, the die, which is kind of what you need, and it looks like they send you a sample one with it. But according to the instructions, you want to get the pipe about flush with the top of the die. So we're doing 3/8 pipe, and so we'll get it about flush there. And then by putting the tool on, it will automatically kind of cinch up. Unfortunately, this one, the box is designed for it to be stored in its completely closed position, and in order to use it, you have to first get it in its completely open position. So the other thing I like about this one, it's got these little detents. So as you slide it on there, it like kind of makes a clicking noise. Gotta get it more open. It's my first time using this particular tool, so I'm a little awkward. Oop, hear the clicking. And there we go. We are at the 3/8 mark. I'm going to tighten this down, and then you probably can't see in there, but as I spin it, the flaring tool will come down and roll that flare. And this is really smooth. It's supposed to click when it's reached the set torque. Oop. Yep, I felt it. It's got a ratcheting mechanism that breaks loose when the flare is complete. Then you back it off, and then loosen this up. And then the tool should just come right off. There we go. Oh wow. I don't know if you can get a view of that, but that flare is much better. This is some scrap piece. I just totally kinked it. But yeah, go ahead and look at that flare. Look how shiny it is. Pretty much perfect. So I'm trying to do a few practice runs with this tool before I go make my actual refrigerant flares. But I heard a comment online that this weird notch that's always in these roller tools is actually specifically for this, when you want to cut off the flare that you just made because something got messed up. And so you can fit the flare in the tool and make like a really, really short cut to redo the flare without cutting off a ton of tubing. But even this flaring tool makes it really nice. But this cut-off tool makes a really nice flare. And they give you a spare blade. I really like the click. Make sure that you're perfectly lined up over the head of the flare. And this one kind of wing nut operation is pretty nice too. Yeah, another absolutely gorgeous flare. I think I'm gonna take this tool and redo all the ones that came with the unit because these are slightly better. So go around and do that. I also really like this box that came in. It's with tools like this that you only use like once every 10 years. Like it's really easy to lose all the parts and not be able to keep it all together and organized. Like boxes like this, these big blow molded, they're kind of annoying to store, but at least it keeps all the parts together so you know you have a complete set when you have to go do this again. Yeah. The mom's just hammer drilled a maybe 6x4 inch hole in the wall for the mini split line sets. So we'll come in out there, go up the wall, and then shoot across the house. So there's some I laid up there, just temporarily. But they're pretty worn out. A lot of hammer drilling. We mounted our mini split in the ceiling, just on some unistrut, 11/16, and we put a brace across the trusses, nailed it in, and that gave us some adjustability. One challenge I keep running into is finding a way to duct to the return on these mini splits. So that return duct up there, the flange is like 23 by like 7 or 8. So it doesn't fit between typical truss bay or stud bay, which is 24 inches by an inch and a half, so 22.5 inches. They make it like just a half of an inch too big. So if you turn it sideways, get it to fit, parallel to the trusses. So you can actually angle that return flange down. You can see this bolt pattern down here, but you basically just take that plate off and move that flange down, and then it points down. And I think this one in the garage here is going to be easy because I can just kind of point it down and build like a box to hold my return air filter. But I'll show you some of the other ones in the house. It gets kind of difficult. Here's the air handler in the kind of great room area. So I got my supply. That's easy. I'm just going to run some flex duct. My brother built that that plenum up. It's our first time working with sheet metal, so not perfect, but he did a really good job. It's nice, and all the corners are nice and tight, and then we painted it with mastic, so it's completely airtight. But yeah, here's the return side of it, and as you can see, it's like just slightly wider than the stud bay, so I can't just orientate it straight down. It'd almost be better if I turn the unit 90 degrees, but I'm gonna have to get a little creative with a sort of like inset offset sort of thing before I go down into the stud bay where the return air filter is going to be. Wife is pulling some of the circuits for our back porch and dinette lights. Got all these cans.
It's great fun.
Yeah, she's up in the ceiling right now. She really doesn't like ladders.
I don't like height.
This thing is a 4-zone mini split, so it's actually got 4 different refrigerant taps in there, and the main power is powered through a disconnect that runs back to the load panel, but all the indoor units don't actually go back to the load panel. They connect directly to this thing. And I thought the connections would be something like 2 hot wires that are always on, and then a signal wire for communicating with the indoor unit to turn it on and off. So I figured 2 wires for hot and hot, and then 1 wire for each mini split, so maybe 4 more wires. So I was thinking 6 wires. No, each unit needs its own hot, its own other hot L2, and a signal wire. So that's 12 14 gauge conductors I got to be able to run from this main unit into each unit. So that will legally fit in this 3/4 inch liquid tight, but it's gonna be a tight fit. I think that's a little ridiculous. It would have been nice if it was 2 bigger conductors that go to each unit and a signal wire. I don't have this thing mounted yet. I'm going to put a concrete pad under it once the house, once the dirt around the foundation settles a little more. So right now I just have it up on a pallet, but it's allowed to be within 6 inches of the siding on the back here. So even though it's got the radiator back there, I can get really close. So it'll be nice tucked up against the house. You can see there's so much settlements going on. My mom actually was working with Morgan's mom, and they got this all leveled out by hand with a shovel. They always kind of get the crappy jobs. And since last Saturday, it's already settled that much around where I dug out for the conduit for the service. We're getting the mini split wired up a little bit at a time. This weekend I put the service disconnect in for the mini split, and got the liquid tight flex. This stuff is crazy expensive right now. I think it's like $4 a foot. Ended up buying it on eBay for I think $60 for 50 feet, so we got a really good deal compared to what I was seeing at Menards. But yeah, these connectors are dual rated. They're typically designed for liquid tight metallic conduit, so it's got the metal inside. For this application, liquid tight non-metallic conduit's fine, but these are also rated for that non-metallic kind. And typically you see these plastic ones, and these things are always breaking loose. The hose is always coming off, and you see the wires exposed and the hose just kind of dangling. But with these, I don't think this is coming off. It's got an insert that goes into the tube, and then it's a compression connector. So I think this could be a really solid connection. This is another kind of annoying thing about ICF. We have these Fox blocks stripes that go up the wall and are spaced every 8 inches, and they're supposed to function kind of like studs. But in a lot of applications, it's just not strong enough to do something like, hold on to an electrical box or hold on, to a load panel. There's no way I want that thing coming off the wall. So you have to, in the case of the load panel, what I did is I just put it on some unistrut or off-brand strut, and I anchored that to the concrete with like a Tapcon. And then it's really easy to mount securely. But in cases like this and the spigots, I did the same thing, where I cut a channel into the foam, and then I could anchor this piece of pressure treated 2x6 to the concrete using Tapcons that go all the way through, so that's really rigidly attached. And the Tapcons are holding against the wall, the foam's pushing it back away from the wall, so it's really rigid. And then what I do is I put a piece of this PVC trim on top, and that's kind of decorative. It looks nice. And then when I have my box, I can use stainless steel screws that are like 2.5 inches, and they bite into this pressure treat, and that way I can kind of I can put Tapcons wherever I want on the pressure treat to get it anchored to the wall wherever I can get a good grip. And then because it's a big piece of pressure treat, I can drill in anywhere wherever the mounting holes are for this box. Okay, let's just open up so you can see whatever the specific mounting hole pattern is. These are a little tricky. And I can just drill through the back of it, and then I'll hit the pressure treat and it'll be securely attached. But that way I don't have to worry about trying to drill a Tapcon at that very precise location. This conduit connection is another thing I'm kind of proud of, because it goes through the wall, and you can't access the set screw or anything like that once the box is mounted. So like, what do? You stick a piece of conduit onto a connector, and then you set the set screw on one side and stick it in the wall. But then when you put the box on the other side of the wall, like, how do you attach how do you attach that box to the conduit, because you can't access the set screw because all of a sudden it's in your concrete wall. So what I ended up doing is I put my connector on this end, set the set screw, and ended up using a compression connector just because it's more liquid tight, and it's actually not as deep, so I guarantee that I don't hit the concrete. But on the other side, I used these, on the other side of the wall where I need to get to a box, I use these, they're called Sim Push LBs from Southwire. So instead of using a compression connector or a set screw, it's kind of like a shark bite. You just push the conduit into it, and these little steel dogs bite onto the conduit. But the nice thing is you have to use a set screw. So normally where you have to get back in the wall there to set the set screw or turn the lock nut for a compression connector, with these you just, you know, mount the box to the other side and then just push it on, and all of a sudden it's in place. And there's no way I'm ever going to be able to get that off, but you know, it's in place now, and it's, you know, relatively rain tight. It just runs up my wall. I've got a big junction box in there because I ran out of big box, or the 6x6s, so it's like an 8x8. But that's for the air conditioner. The ducted mini splits have extremely low static pressure. Where a typical air handler might have a static pressure of 0.5 inches of water, a ducted mini split can only generate like 0.1. So you kind of have to eliminate resistance in the ducts wherever you can. And one way to do that is at the return register. So I just got my return registers in from Supply House, and this thing looks truly obnoxious. It's a 4-inch pleated filter, but it's a 20 by 25 return register. I don't have my hand for reference, but this thing is massive, and I've got 4 of them. They're a little pricey. I think they're like 150 bucks a piece because they're kind of custom from Supply House. But I got 1, and the other 3 are apparently shipping soon. But the nice thing about this is it's really hard to fit a filter in the duct path for a mini split, because normally where you just kind of make a slot next to your air handler in your utility room and slip a filter in there, there's really nowhere to slip a filter in with a mini split because they're all in the attic, and I'm not going to climb up there to change a filter every 6 months or 2 months or whatever. So I got these special return registers that allow you to put it right in the register. And so this will be hanging in the ceiling, and when you want to change the filter, all you got to do is move these plastic clips, and they're great. Will hang down, and I think it's supposed to hold itself in place, but it doesn't seem to do that. And you can just pop the filter out. Look at that thing. The other benefit of using a bigger filter like this, really there's a huge difference between a 1-inch pleated filter and a 4-inch pleated filter in terms of resistance. You get like more than 4 times less pressure loss drop. But the real benefit, I think, is probably the increased filter media area. So you really don't need to change them as often because there's just so much more filter area to get coated up with dirt before it clogs. These things are like 30 bucks, these filters at Menards. But I got this one with the return grill off of Supply House for like $13. And there's a whole box of them over there. 30 degrees and silver worms. We have an R8 vapor barrier coated flex duct that we're running into a couple registers in this room. I probably could have thought out the layout a lot better, but I'm putting 3 registers in this room. And then I gotta pick up some additional registers in the other rooms. This is our biggest mini split here. It's the 12 kBTU one. So we're hoping that once we get some insulation in here, it should be able to heat the house for like a couple months. Like it should be plenty of heat until at least, you know, January, February, when we start getting those sub-zero days. But we'll see. We'll see. Right now we've got the 120 kBTU Mr. Heater going. We've got 30 kBTU of mini splits going, and we have another 5 kBTU net from the fireplace, and it's still like 38 in here. It's I think it's 32 outside. So without insulation, we don't really have a chance of keeping it warm in here at all. So we're kind of rushing. We blew out all our PEX lines. We filled the toilets with marine, whatever that propylene glycol antifreeze stuff is. I tried to pump as much of it as I could into the boiler and into the expansion tank and the radiant heat loop, but you know, it's really hard to get all the water out of the manifolds and stuff like that, so I still really don't want this building to freeze. So we're doing our best to try and get the flex duct up so we can start shoving insulation up in the attic.